contest. We licking off shots in the west. We make believers out the best. Lay the weak to rest. In Southern California, that ain't no place.
Okay, so this question tells us to find the arc length parameterization of r of t equals e to the t sine t, e to the t cosine t, and then e to the t. Okay, so we're going to follow steps here. So the first thing we're going to do is set up our arc length function. So first step, set up this thing, s of t, that is. S of t is equal to the integral from 0 to t of the magnitude of r prime of u, we're going to use, du. Okay, so first of all, we have to find, so r of u, first of all, we're just going to replace all of the t's with u's, just for the sake of notation, right? So r of u is e to the u sine u, and then e to the u cosine u, and then e to the u again, lastly. Alright, that was a weird u, hold on. I'm going to leave it like that. Okay, so now we just have to find the first derivative of it. So r prime of u is going to be the following. It's going to be kind of lengthy, so I apologize in advance, but let's start. So we have e to the u, and then we differentiate that. So we have product rule for at least the first two terms, right? Or the first two components here. So e to the u cosine u plus e to the u sine u. Okay, so that's the first one there. And then for this next one, we have e to the u times negative, so negative sine u, plus e to the u cosine u. And the last one is just an e to the u. It just stays e to the u. Okay, so now that we have that, that's our velocity vector. And now we have to take the, magnitude of it, right? So we can plug it into our formula eventually. So the magnitude of this, it's going to be kind of, like I said, it's going to be kind of lengthy. But we're basically going to have an e to the u, and I'll factor that out. Cosine u plus sine u. And all of this is going to be squared. That's our first component, okay? And then we have plus e to the u times, what else? And then we have a cosine u minus sine u in there. And then our last component is just e to the u squared, okay? So we're going to, again, don't forget that square root symbol over the top. Okay, so if we continue, what we get is the following. We have e to the 2u, right? So I'm going to distribute that component there, or that exponent, sorry, that exponent. And then what we have is a sine squared u plus cosine squared u plus 2 sine u cosine u. Alright, so that's the first term. That's the first term expanded, that is. And then we have it added to, so I'm just going to continue it down here, pretend it just extends onto the right, but I don't have room, so I'm sorry. But and then we have another e to the 2u, and then this time it's going to be a sine squared u plus cosine squared u, but this time, because we have that minus sign, that'll be a minus to sine u cosine u. Alright, and lastly, I'll just tack it on to the end here, we have an e to the 2u that comes from here. Okay, so all of this is under a square root sign. Okay, so square root, and it continues, square root ends here. Alright, so now what we can do, so these two here, the positive 2 sine u, cosine u, will cancel out with the negative 1, okay? And then, so I'll let you know on the next slide what this actually amounts to, this last line here. Okay, so what we had was an e to the 2u times sine squared u plus cosine squared u plus another e to the 2u sine squared u plus cosine squared u, and then we just had a leftover e to the 2u. Okay, so we had something like this, right? And these ones here, these sine squared something plus cosine squared something, those just equal 1. So each of these is just equal to 1. So what we end up with is actually an e to the 2u plus an e to the 2u plus another e to the 2u. So that makes 3 e to the 2u's. And that's all under the square root. Okay, and then this can actually come out. This cancels with the 2 there. So we just have the 3 still stuck inside, but then we have an e to the u. Okay, so this was, again, because we've gone through so many steps so far, but this is the magnitude of r prime of u. Okay, so we're just going to plug this in, and find our arc length function. So S of t is equal to 0 to t of, and we're going to plug this in, so radical 3 e to the u du. Alright, so now that we have this, we're just going to evaluate it for t, okay? We're just going to plug in these bounds here. So the radical 3 just stays there because it's a constant, and then we have an e to the u. That's what it integrates as, and then 0 to t. So this is going to turn out to be S of t is equal to radical 3, and then we have an e to the t going on, and then we're going to subtract radical 3 e to the 0. So e to the 0, that's just going to be a 1, right? So this will be 1. And so what we get is a radical 3 times e to the t minus 1. Alright? So this is our arc length function. We started out like by plugging it into the integral thing, right? And then we just continue on through and actually integrate. So we got a function of arc length based on t. Okay, so that was the first step. I know it was kind of lengthy, like I said, so I'm sorry about that. But these problems, when you're finding arc length parameterization, they're usually not super like quick and easy to get out of the way. But anyways, it'll pay off. So keep this in mind. This is our arc length function, and now what we're going to do is step 2. So S of t that we just found is radical 3 times e to the t minus 1. And now what we want to do, so step 2 is to find the inverse. So find inverse. So what we want is t as a function of s, aka g, some, like, you just name it differently, g of s. Okay? So what we want is t by itself. Okay, so we start by dividing by radical 3. Radical 3. We can just consider this an s now, okay, because that's just arc length, right? So these cancel out, and what we get is an e to the t minus 1 is equal to s over radical 3. We're going to add 1 to both sides, add 1. E to the t is equal to s over radical 3 plus 1. Okay, and the last thing we need to do is ln both sides. Okay, so ln both sides, these cancel out, and we get that t is equal to ln of s over radical 3 plus 1. Okay, so this is kind of messy. I'm sorry about that. This can be considered, as I said before, at t of s, because it is t as a function of s, or it could just be named g of s. Okay, so that step was pretty easy, right? And now the last step is even easier. So we're going to keep this in mind, what t equals, and we're going to plug it back into our original r of t. Okay, so r of t, just as a refresher here, r of t was equal to e to the t sine t, e to the t cosine t, and then e to the t. And t, the one that we just found, is equal to ln of s over radical 3 plus 1. Okay, so what we're going to do is just plug this guy, all of the s stuff, in for wherever you see a t. So r of g of s, we'll call it, okay? So r of this function here, this is called g of s, or t of s, whatever, is equal to e to the t. So then we're going to plug in ln s over radical 3 plus 1 up there in the power, sine times this thing, ln s over radical 3 plus 1, okay, comma, e to the same thing, ln s over radical 3 plus 1 times cosine of that same thing, ln s over radical 3 plus 1, and lastly, I'm going to squish it in here, e to the ln s over radical 3 plus 1. Sorry, I had to squish that. And then there's an arrow bracket at the end. I should really think about spacing that correctly the next time. Anyways, okay, so as you'll see, the e to the t parts, those actually just cancel out because we have the ln in the power there. So our arrow of g of s, so our arc length parameterization, is going to be the following. So we just have an s over radical 3 plus 1. We can't really do anything about the ln and the sine, so those just stay there. Sine of ln of s over radical 3 plus 1. Okay, these ones cancel, so we just get our s over radical 3, that's an s, not a 5, plus 1, and then times the cosine, which we can't really do anything about, so that's just an ln s over radical 3 plus 1. And our last component also can cancel out the e and the ln, so we just have an s over radical 3 plus 1. Okay? And there's our big arrow bracket there. Alright, so that basically does it. This last line here, I'll put a box around it. This is our arc length parameterization. Okay? And if you were to have the desire to check that it is an arc length parameterization, what you would do is basically find, what you would do is basically go back and calculate the magnitude of r prime of s, or r prime of g of s. What we have here, basically, you're going to derive everything, or take the first derivative of each of the components, and then you're going to square them, add them, and put the square root sign over them, and basically you'll find that it comes out to equal 1, surprisingly, even though this looks super messy. But anyways, it works out. So this is our arc length parameterization. Alright, so that does it for this video. I hope that helped, and happy studying.